How are you all? My name is Aditya Santosh. I am from first year CSC Data Science A section and my roll number is 701. My concept video is from the subject LAC, Linear Algebra and Calculus, and in this I have chosen the topic that is operator form. So what do you mean by the operator form? So it is also known as the D operator. D stands for here the D stands for the differential operator. Here it is a type of notation which is given to an differential equation. When we write any differential equation, we simply in the short form we keep as capital D in a so as a matter of notation, it considers mainly the differentiation and abstract operation, and also it accepts the function and returning another. So in maths, there are many combination of derivatives which is applied to a function. It can be written in many forms, like such as d square x with respect to x minus d square x y into d square yx. Here the d square which stands for the second derivative of the given function. It indicates also the partial derivatives also. So one question what is d by dx is an operator. So as we discussed d operator, since as d operator is also known as the differential operator. So to answer the question, since d by dx can be thought as an operator also, and we represent d by dx as the capital D, which is derivative of the function. The function dy by dx or d by dx of any function, it can be represented also by single code, single code such as dash here, which is represented by dash also in double quotes, as you can see here. It also converts the function into derivatives, and we represent as f. What are the examples for the differential operator? In the simplest differential operator, the d acting as the function y, and returns the first derivative of the function. So as we can see here, the d by dx, since it can also be written as the capital D, which returns as the y returns. It is also be written as dy of dx, which implies dy by dx into x of x. So differential operator. In any combination of derivatives, there is an applied of functions. It takes form in the polynomial derivatives, such as d square xx minus d square xy into d square yx. Since as we have discussed, d square is the second derivative, the function. In order to gradient the diverse and Laplace operator, the differential operators provides in a generalized way to look at the differentiation. So to understand the D operator or the operator form in the clear-cut manner, we have to look into this complementary function. So what is complementary function in this? A complement function, it is a general solution of the homogeneous linear differential equation. So if any differential equations such as such as the second degree or third degree, any type of degree of the differential equation, any degree of the differential equation, we can make use of this property, which is of this complementary function. Yc of x equals to ay of x a into y of x. Here a and b are arbitrary constants, and so to find the general solution, f of d into y is equals to 0. So f of d, which is written, so f of d is an the linear differential equation, or we can call it as a polynomial. To consider the auxiliary equation, we can write in the place of d, we can write as m. Here m represents the slope. As we all know, in the previous classes in the intermediate, we have learned the slope is equals to the derivative of the d, which is slope m is equals to dy by dx, which is differentiation of the function f, and p1 p2 p3 so on other real constants for it. And to find the roots of the function, these are the m1 m2 of the given roots. Depending upon the nature of the roots, we consider many complementary functions. We can write the given complementary function as follows. So as you can see in the given table, these are some of the roots, as you can see. So in the first one, if m1, m2, m3 which are real and distinct, means they are different, which are not same. We can write as c1 into e power m1x and c2 into e power m2x. Here m2 represents the roots of the complementary function. So how to find these roots? Actually, it's very simple. In if the given if they given in any question, to find the differential of to differential to find the complementary function of that given differential equation, first of all first we have to given first we have to convert into the operator forms, such as such if they give if the such if they given such question as d square y by dx square plus 2y 2 dy by dx, or second degree equation, third degree equation, we have to convert into the operator form. Like after converting to operator form, in the auxiliary equation, we have to take that particular differential equation into the slopes form auxiliary equation, such as m square minus m2. We'll get the given roots. If m1 m2 of the so on are real roots, we'll get c1 into e power m1x plus c2 into e power m2x, so on. And if both roots are equal, such as c, we can write as c1 plus c2 into x into e power m1x plus c2 into e power m2x. And for the complex, if the roots are given as the complex, we can write as follows: e into a power c1 cos beta x plus c2 sin beta x. So these are the given cases to find the complementary functions. So let us see one question here. To solve d cube y by dx cube minus d square y by dx square minus 3 dy by dx plus 2y equal to 0. So as you can see in the given problem, first it is given as the normal differentiation. First we have to convert this in the operator form. Actually no need to convert into operator form also. You can simply write it as m cube minus 3m plus 2 equal to 0. This is the auxiliary equation for the given question. So the roots, so we'll get as m cube minus 3m plus 2. Here we have to take the y separate, common. We can get it as d cube minus 3d plus 2. So the roots are 1 1 1 2. So this is the cube, as you can see this is the cubic equation. We'll get three roots here. So since as you can see here, this one and this one are are equal, so we have to combine this as c1 plus c2 into x into e power x. This here, this is m1 here. M1, in the place of m1 we'll write 1, and plus c3 into e power minus 2x. This minus 2 is real and distinct, so we write as separate minus 2x. And sim as you can see in the next question, as you can see here, d power 4 plus 8d square plus 16 into y equal to 0. We have to convert this into auxiliary equations, such as m power 4 plus 8m square plus 16 is equals to 0. So this the roots are given as 2i 2i minus 2i minus 2i. Since these two roots are same and these two roots are same, and we have to use the given case which I have shown in the table. yc the yc represents the complementary function, and we write as e into e power 0x c1 plus c2x cos 2x. Here the 2 represents beta we have written. So thank you all.